Hello friends, my name is Salman and you are watching my channel Solid Tech. In the last video we have completely discussed about the layer 2 addressing about data link layer. Now in this video I will discuss the switching function of how to switch work, how the MAC address table work. So before starting this video I will recap my previous video. In previous video I will show you what is the data link layer and what is the frame. Basically frame is the chunk of data with the data link layer headers. So I will describe each field of data link layer header in the last video. As you can see, we have a destination MAC address, we have source MAC address, we have a type and FCS, which is frame check sequence. Basically destination MAC address is a MAC address or a physical address of any host which I want to communicate, and the source MAC address likewise is the MAC address of our host, which is our client, and type describe which type of data this frame carrying. For example, it can carry up to IPv version 4 data and IPv version 6 data or DHCP data, and finally FCS is used for checking error detection and error correction. So now in this is very important video in terms of concept. In this video I will show you the concept of Ethernet switching, how the switch works with the help of MAC address table. So for example, in this video I will show a centralized device which is called a switch. Basically switch is represented by two double arrows in opposite direction. On each switch I have connected my PC, lengthwise I connected my 6 PCs on this switch. Every switch have a NIC card, network interface card, and as we discussed earlier, every network interface card have some physical address or MAC address. So in this demonstration I will give the MAC address like A7, E6, E3, E3F, BF and C2. For understanding I will not write down the whole address which is 48 bit or 16 byte hexadecimal. Instead I am using only 2 digit for simplification and understanding. For example, in each host we have a MAC address. Now for each MAC address in every switch there is a table which is called a MAC address table. What MAC address table is composed of? MAC address table is composed of 2 columns. One column is called port and other one column is called MAC address. Basically this column is populated by the switch every time any communication occur. So let's take an example. When we switch on, the MAC address table is empty, there is no entry in the MAC address table, and when any computer goes on, it will send some traffic, some frame on a switch port, and switch port will listen this traffic with the help of a chip. There is a chip of every port of the switch which is called A6 chip. Basically the A6 chip is application specific integrated circuit. What its function? A6 chip is used to read the frame headers MAC address of the source machine, because every client has a MAC address and it read the MAC address of the attached device. So ASIC is used to capture the MAC address from the connecting device and put into a MAC address table. For example, it will read whenever any frame reaches to port 6. It will A7 is reached to send some traffic to the port 6. It will read the MAC address table and put this MAC address table in MAC address into a MAC address table. For example, as you can see, now my port number 6 listen the MAC address table from its clients and put into a MAC address table. Likewise, all the devices when boots on send some traffic and their ASIC chip sends their MAC address and populate the MAC address table. In this way the MAC address table is full and functioning. Now if in case of for example my client A7 want to communicate with the B7, so it will send a packet on its ports its switch port 6, and on the port 6 its computer look for a MAC address, the switch look for the MAC address table and find whether this B3 exists in MAC address table and which port it's belong to. So as you can see, B3 exists on the port 2. So in this way, the switch will create a temporary circuit between the A7 and B3, and all the communication happening on this switch. So as you can see, there is no collision domain in this scenario. As we see in a hub, we have a collision domain. All the traffic can be collide each other because they have no intelligence. But in case of switch, the traffic is isolated from the other traffic. So now at the same time, other client C2 wants to communicate with the E6. So it will also send the traffic to the switch, and switch check whether this MAC address exists in its MAC address table or not. But whenever it find a entry of E6, it will create the circuit between the E6 and C2, and all the communication happening at the same time. So in this way, the switch is working. Switch is creating a temporary circuit between the communicating devices. So that's why switch is more efficient, because it is isolate the traffic from one communication to the another communication. Now, what is MAC address aging? For example, in some reason the client 3F does not send a broadcast message or any other traffic on a switch, and switch have ability after 30 seconds it will wipe out all the information related to the port information and MAC address table. It wipe out all the information related to the MAC address table and port mapping. So if A7 like to communicate with 3F, it will look for a 3F entry in a MAC address table, but it didn't find any entry related to 3F. In this case, it will send a traffic all the ports except the A7, and the port which is having a address 3F will only respond to the switch, and switch will again go back to the A7, and the circuit will established between the A7 and 3F, and the same time the MAC address again populated with the 3F MAC address. So the communication is happening in this way. Now the flooding. Flooding means when a computer send a traffic to all the ports of the switch except itself. So when the destination MAC address of the frame is not in the MAC address table, the frame is sent out all the active interface except in the receiving interface. As I told you, if it didn't find any matching entry in the MAC address table, it will send the traffic all the ports of the switch. So this is called the flooding. Now there is another concept of the broadcast. As we can see that the Ethernet frame is composed of the following field: destination MAC address, source MAC address, types, and FCS. But if we put a specific destination MAC address in a Ethernet frame, which is about FFF, this address is called broadcast address. Basically, what is this address does? It will send the traffic to all the ports of all the port of the switch. Basically, this is the broadcast address. It is very used when a switch want to know the exact location of the destination port. So broadcast, when the destination MAC address of the frame is all F, the frame is sent out the all active interface except the receiving interface. Basically, the broadcast is very common in the switches. So but in router we don't have a broadcast domain, but in switch we have a broadcast domain. So this is the basic difference between router and switches. If you like this video and you got the concept which I want to deliver to you, then in this case please like my video and subscribe my channel, so I will upload the video like this in future. Basically, this is a very fundamental series, so you will get the concept of what is switching, what is frame, what is MAC address table, what is encapsulation, what is packet header. So I will describe and very ground level of these terms. So I will gradually making a difficult video as soon as you have some solid understanding of the basic concepts. Thank you very much for your time.